We are expanding Hednesford Town Football Club. Take the tray up. What are you looking at that for? This is a £750,000 hybrid pitch.
Are you grabbing it up? Yeah.
The original battery, yeah, that's in the wrong place. This turned into an absolute nightmare.
Everybody was kung fu fighting.
Oh, that's right, be careful.
But they fought with expert timing.
Perfect. We are back at Hednesford Town Football Club fitting more PV to this stadium. But it's not just PV, we are expanding that original Alpha H50 battery, which was massive anyway, with 3 more batteries. They have gone wild with battery storage here, and it's all to do with the problem with the grid. The power demands here are going up and the power supply is going down, but we have the answer now. This job has been a bit tricky because we have had to bury that cable for 100 metres using a digger through concrete all the way back to a plant room. The original battery, yep, that's in the wrong place. We've got to move that, and the one we're putting next to it, it's too big for the door that we installed around the original batteries, and we had a monumental cock-up with that battery. I don't think it will actually make it across. Give me 2 seconds to bring it back. It nearly brought the whole project to a halt, but you'll find all that out later on in this video.
Oh, that makes some funky old noises. I've been in here putting the datas in, and yeah, there's some funky noises coming out of that thing.
Quick recap of this job as it was previously. Now, we installed 227 REA Fusion 2s on that roof up there, but we had an issue with the brackets.
These middle panels are about 100mm higher.
Now, I thought I'd sorted this on the first day and the roofers had it absolutely sorted. It's great, it's all worked out. Turns out I was wrong.
How are you, Mr. Price? You are currently on camera.
It's not their fault.
Okay.
So I took the opportunity once I realised it was my mistake to get on the roof, have a meeting, apologise, and I took my punishment like a man.
Well, that got sorted. We got the panels on the roof, and whilst it was a nightmare, it wasn't as bad as this battery because we got this on the pad, we started installing it, and we realised we couldn't get to the back.
You can just see there's a cavity behind there. We can't open the bloody door. No!
And with that battery now wrestled into its new home, there was only one thing left to do, and that was for Sophie to lock the keys inside of the battery and ruin everyone's day.
So what's happened then? We've locked ourselves out?
That's pretty cool, though. On a...
Yep, that's less relevant right now. But we got it sorted, we got the system live, and we were saving money. There is a new problem now, thankfully not caused by us, it's caused by these guys, the grid. We're going to get back to that later on. First of all, what I'm going to show you is why do we need so much power and what are we going to do to fix this problem. Now this is one of them. To anyone else, this just looks like grass, but this is not any old playing field. This is a £750,000 hybrid pitch that is heated and cooled and uses a ton of energy. It's called a hybrid pitch, so it's like grass and fake grass.
A bit like AstroTurf combined?
Yeah, combined in one. So like in the goal area and like round the pitch, it's much more stable all year round. It's got like brand new drainage, it's got a heating system, a cooling system, so like defrost it, you can like stimulate growth. And we've got this huge score screen. Now these things are like 50 of the biggest TVs you can buy, the brightest TVs you can buy, all wired together to project that winning score. But what it also does is kick our energy meter into overdrive. Now, to pay for all of this investment, the club needs to sell advertising, and to sell advertising, you need LED boards. Well, they're being installed just along here. In fact, they're going all around this perimeter, and they use huge amounts of energy, much more than I actually thought they do. Now, usually this wouldn't be a problem because you just take the power from the grid if you haven't got enough coming from your solar, but not in this case because the grid, they have said no, you can't have any more. Well, you can't have any more for free. They want to charge a huge amount of money to put a substation in to give the club extra capacity to power all this equipment, and that price is not far off the cost of that pitch. But we have a solution. When the club plays its games, and you've got that scoreboard on, you've got the LEDs on, we've got the hospitality unit, the pitch is running, the canteen's going, we're using a lot of energy, and we've had an energy monitor on this, had a data logger on it, and we are getting to pretty much the limit of what the capacity allowance is from the grid itself, because managing energy demand and flows is super complex, and you have to keep the grid in balance. Now, not all demand comes at the same time. It comes in waves, and sometimes you get a big peak, and when that happens, if the grid isn't balanced, then the grid falls over. And when the grids fell over, the grid shuts down. The customer has two options. He could spend like a load of money putting in a new substation, and that's time. It's a huge amount of cash. Or he can find an alternative power supply. Choice one was a diesel generator, but this is a renewable customer. He doesn't want to use a diesel generator blowing fumes all over the supporters, so the alternative was battery storage, and not just any battery storage, a big system set up in a way to do something called peak shaving. It's all a bit complicated, but basically this battery is going to solve the problem. But also, the grid in this area is in a pretty bad condition and it needs help. This battery system is going to help provide the solution, and along the way, the owner of the club is going to earn out of problem solving.
So, with the groundwork laid, we finally had a chance to inspect some of the physical changes that had taken place since the last time we were at the club.
And we're lucky because the DC comes from that way, so we've not got to join anything up with, it can all come off there. So I think you'll probably end up just changing that tray, hopping it over here, bringing that tray down there.
Because not only was there this new outbuilding to house the H50, but there was also a ton of new gear to support the scale of the system.
And then we've got these new boards that have gone in, so we're going to get the power from there. Solid.
No, from there.
That one.
No, actually.
What confused me though was why they were wanting to install a whole new breaker on top of the ones that were already there.
You can't call off MCC board. Look, come with me. This is essentially a fuse board, 4 fuse boards. Yeah? So that, yeah, is obviously single phase.
Going to that.
Goes to that board.
Oh.
Okay? So that gives that 100 amp supply. We're putting another board in just here, a 3-phase DB, and running everything via that.
Off an MCCB.
Of this board, yeah, everything and stuff like that. Because you can't just connect straight up into one of them.
Now, all of this is super complex, but luckily for us, we have Alpha on the case. They're going to come down, they're going to set up the system, commission it, sort out all this peak shaving malarkey. What we need to do is install the hardware, and this one battery just isn't going to cut it. We have these two. Now, this isn't just battery expansion, this is a paralleled system, because this is just raw storage like you would expect to see. Battery cells, these are the thermally managed, heated, cooled, air conditioning, fire suppression, all that. but we're paralleling the system because we need more power. It's not just about storage, it's about power. We have a battery inverter and battery expansion pack here. So this is the same as the original H50 that's down there. This is going to do the PV inversion. It's going to let DC current from the roof go straight into the battery, but it's going to be connected to the other battery because we have 50 kilowatt here, 50 kilowatt down there. Together that gives us 100 kilowatts of instantaneous power when we need it. Battery systems like this weigh an absolute ton. 2 of them weigh 2 tons, and this earth is actually quite firm, but it wasn't firm.
Great. Can you find a soft spot? Is it just
There.
Did you just get unlucky?
Yeah. And this earth here is pretty soft. So what we had to do is get a concrete pad that could take the weight of 2 battery systems so they don't fall over, they don't sink, and it sort of raises them up off the ground. So this was done about a week ago. It's all set. They've been dropped on and it's not moved. This is the power cable that's going to power and take energy away from that battery inverter system, but it's also going to make it a parallel. We have another cable which is the auxiliary supply for the air conditioning in both of the units, and we have comms because the 2 systems need to communicate to each other. They're about 90 meters away, so we had to put these trenches in, we had to put ducts in, we had to put the cables inside the ducts, which was a nightmare because it weighed about 2 ton. Pulled it all through, got it in the ground, cemented it in, and we're ready to install these batteries. But there is another battery to get this system fully functioning. We have this one here. Now this looks a bit different to the others because it is from the same family. It's a H50 expansion pack. The other one on the left-hand side was a H50 expansion pack, but that's the IP rated version. This is the non-IP rated version because it's going inside the little garage thing the guys have built. So it's a little bit thinner and it goes on the same side as the other one. It needs to go on the left, but come and look at this for a problem. Well, there's 2 problems, 2 solutions. Whilst that battery is smaller, it ain't that small, and it's got to go on the left hand side because on the right hand side we have the inverter and the PCS. We have to move this battery. We've already moved this battery. In the previous video we installed this back to the wall, then realised there was a door at the back and had to move it fully loaded with all the cells. It was about 1.3 tons. Nightmare. We thought that was the last time we had to move it, but no, we need to do it again. We haven't worked out how we're going to get that here. What we did realise was the ground was not the same level. So we had to extend the pad. When we put the battery pad in around the back for the other 2 units, we extended this, we raised it up and made it in line with this raised section here. The options we have are we jack this up and roll it like the Romans or the Egyptians used to do back in the day, sort of 5 foot this way, or we have a telehandler on site. We don't know if we have enough of an aperture there to pick it up and move it across to bring the other one in. The other issue is a little bit more tricky because this door frame is not as tall as the actual battery. So what do? Well, we're going to take the door frame out, we're going to remove this lintel, we're going to have to get acro props to hold the roof, and then we could take the brickwork out, put the battery in after we've moved the other one, and then re-brick it all up, put the doors back in, close them, on to the next job.
And this really was what was intended for this job. It was practically foolproof and it was definitely easier than what we actually ended up doing.
When that goes, that's
But if you've watched any of our videos, you won't be surprised when pretty much every part of our master plan goes completely tits up. Now, before we carry on installing that battery, we have got a pile of things to get through. We've got a roof that is full of rocks. We're not sure why. We've got Wacky Races telehandler driving, and it's heatable, so we'll need to smash some panels.
Now, with all that extra storage available to the club, they need to fill it, and they can fill it either by charging overnight when the grid has cheap energy and when the grid's not really under much stress, or they can use more panels because we put 250 and 27 on the original roof. And that battery charges really quick when it's sunny, so there is excess. But the client wanted more panels, and here they are. Now, they are the same panels. It's the REA Fusion 2. We've got 1, 2, 3, 4.5 pallets. There's 160 of them. Once the batteries are installed, it's going to be time to get these panels on the roof. But we're going to have to think about this because this is a parallel system, and parallel systems need to have parallel behaviors, i.e. they need to be the same. So we can't have certain panels stringed in a certain way over there and certain panels stringed in a certain way over there. It needs to match perfectly. Now, we've worked this out. We've been working with Alpha. We've been working with REA to make sure we get this right. We have a plan. We need to follow that plan.
How many monkeys did it take to shut a door?
You break the door?
Yeah.
Now, we've got 2 loading bays here, and what we're going to use is a telehandler to pick the pallets up, bring them onto the loading bay, and then that's going to give us easy access to get on that roof. What the guys have been doing all this morning when we've been working on the batteries is getting the roof mounting system on. Now, it's a different system to the one we had on the original roof because it's a slightly different design. Before we start installing the panels, we can take a look at those mounting brackets, have a look at the layout, and then I can show you how this system is going to work with the other system in parallel. From a layout perspective, all of these panels are in a landscape formation, so they're going straight left to right on the roof, and there is 1, 2, 3, 4, I think, runs, 160 panels in total. That gives us about 79 kilowatt peak worth of power. And what we need to do when it comes to the wiring is match it to that main roof. And again, this is all to do with that parallel system. We need to try and get it as identical as we can so we don't have one battery or one side filling up quicker than the other. Now, we've been working with the Alpha technical team on this. We've sent them the panel specifications and the orientation. We've done the wiring together. Now, once all that wiring is done, it's then going to run on this tray. So those DC cables will end up in blocks of modules, and each module block will then be run onto this tray. This is a galvanized cable tray, and it has little spaces in between, so once you've run your DC on, you can secure it down, because what you don't want on a roof is DC cables whipping about or rubbing on any sharp surfaces. So they'll all get clipped there, they'll be marked up as high voltage DC cables. What we've also done on the tray is use the same EPDM washers, tech screws, and underneath the tray we've got some little foam pads. So what these do is they seal the tray to the roof, because the fans are going to be under this stand, so when it's raining we don't want lots of little holes getting them wet.
So while I checked out the roof and all its fun quirks,
we keep finding loads of bricks and rocks. We don't know if this is from like away fans throwing them on the roof. Hopefully they stop doing it once the solar panels are on there, because these are pretty chunky rocks.
the lads were at the same time coordinating with the telehandler operator to get 160 panels up some scaffolding, 1 pallet at a time.
Looks like the first couple of panels are starting to go down, so what we'll do is go and get in their way, slow them down, really annoy them, and just be a general nuisance. So come with me. We've come over to be annoying,
Obviously.
but we were just saying these brackets are much better than the ones we used up there, aren't they?
Yeah, they give you more room for manoeuvre. Whereas on those other ones, they were what, 150 mil
Well,
long or something.
yeah, by the time you had a panel on a panel, you had like 20 mil, didn't you? Either side. Whereas these, so like, will you like fix all these exactly, or will you do a run and then move it about, or do you know where they're going to land?
Well, so far the marks I've made, I'm landing bang on them. So.
Oh, Okay. So you mark them and you measure it out.
I've gone, yeah.
Right. Okay.
Just because I didn't want the same problem as up there.
yeah. And we reckon
We've
this
done
one.
them a different way. As the other rails, they run down these strips, down the corrugation, didn't they?
Yeah,
So
well,
we
these
were
go
clamping
across.
that way rather than that way.
Yeah, we were clamping on the ends, weren't we?
Yeah, they're coming down.
Right.
Whereas
yeah,
we're
yeah.
kept clamping across now.
Is that easier to get to? Is it, or is it just the same?
The same,
Is
really.
it? Cool. No, we're going to hang around here, get in your way, and then we'll film you. Now, on the subject of panels, this is a good time to talk about the specification of the panel on this install. This is the REA Fusion 2 Type R. Now, we have just done a full product review of this panel on the Heatable YouTube channel. There's a link to that somewhere here, or it'll be in the description, and I would recommend that you watch that because it gives you all the specs of the panel itself. But the headline numbers, 460 watt on the front face, but this is a bifacial panel, so it has something called the BNPI rating. That's its maximum capacity, I think, with 10% of light on the rear of the panel, and that makes it 515 watt. I know what you're thinking, this is a bifacial panel, how on earth does any light get to the back of it if it's going to be lying flat on the roof? Well, I will show you. In between of all of the cells is this clear section, and this is what allows light to get to the back of the panel. So when it's laid down on the roof, the front side will start to absorb energy and produce power. Now, light will hit the front of the panel, and this clear section will allow light to get underneath the panel. Once light is underneath the panel, the rear side can also get activated. I've just noticed we've got one panel up there. I don't know if you'll look up and take a look. If we were underneath that panel, that is what we would see. So there's a reasonable amount of light that's going to travel down onto the panel, make it through the bottom, and that is what's going to power that underside. That other roof has got these panels on it, and the performance has outstripped the performance estimates by about 25%. So these are really premium products, they perform really highly, and they're going to transform the energy position of this club. We were just filming that quick panel review then for about 35 seconds. We've turned round and there is already 9 panels down on this roof. So my expectations today were we'd probably get like 20 panels on. There's a reasonable chance by the end of today we'll have that entire run done, maybe even 2 rows.
Now, whilst the guys are going to crack on installing those panels on the roof, we finally got on to tackling that battery. We've got to get it in a space that's smaller than the battery, so this will be interesting. But before we could crack on with that, we had to take a minute to face the facts. Earlier in the video, we explained our original plan where all of our battery moving problems would have been solved with a telehandler and a quick bit of brickwork. Well, sadly, that is no longer an option.
Plan now is, that's all powered down, disconnect all the DC off the roof, disconnect the AC, take the tray up. What are you looking at that for? Take the tray up, and then we're going to move. Are we going to move this across if we're not got a telehandler? Has it got holes that way?
Well, the storage has. So
Has it?
I need to take the skirt
I can't remember what's under the skirt on the sides.
If not, it's going to be like that Dr. Evil thing, isn't it, when he's on that car?
Yeah. But he's got the really long car in the
In the tunnel.
baggage handler.
Yeah.
Now, you might be wondering why we didn't just take those bricks out, use that telehandler, take the old battery out, get the new one in, and it all would have been super simple. Well, there were a couple of reasons. One of them was I had a bet with Jez that for 20 quid he couldn't do it, and I didn't want to lose that bet. Jokes aside, the real reason was that our brickworkers, unfortunately, had let us down at the worst possible moment. Because of this, our schedule had just gotten quite a bit more unworkable if we wanted to wait for them to reschedule. We were running out of time on this job. Season starts in a couple of days. We've got to get this in, and we haven't got time to make that brickwork good again in time for the season starting. So this is our option.
What they're doing now is lifting all of the tray off the ground that was next to that original battery. Because we're going to shift it over, we need to move the tray, but we also need to move all the cabling. So everything's going to go to the right. We need to modify the tray because it drops down now and goes left. but now it needs to come down and then come down again to get to the new location. So 15 minutes or so, I think they'll have that done, and it's going to be time to move that battery. Hopefully we can get that pump truck in, lift it up and just drag it back, and it might be very uneventful for YouTube, but a massive result for us.
I got my mind set on you. I got my mind set on you. I got my mind set on you. Got my mind set on you. But it's gonna take money, a whole lot of spending money. It's gonna take plenty of money to do it right, child.
Even though it was a bit fiddly in places, the boys got that full-sized H50 moved over without too much hassle.
Decent job, Basie.
The hard bit, however, was still right there in front of us, waiting to be moved.
We might have to do a cut where we go, and we couldn't show that, but it's in.
Of course, we handled it with care, with our minds firmly focused on the relevant safety guidelines.
Now, unfortunately, the camera faulted and we missed all the action there, but it was really safe and we got it in really easily, so no problems at all. Here it is. This is the expansion cab. Now, a little bit different to the other one because this is a non-IP rated, because it's obviously indoors, it doesn't need to be weatherproof. This one originally was outdoors, then they built this around it. So what does this actually do? Well, this is just raw storage. It doesn't have an inverter, it doesn't have a BMS, a battery management system. It's a cabinet that holds capacity. I'll show you inside it so you can see what I mean. You've essentially just got an isolator, you've got your comms that will link from this one to this one, and the power connections via this positive and negative cable. So they'll drop round, there'll be a gap at the bottom, and then the battery cells will plug into there. And if you can see at the back, this is like a buzz bar here. So the batteries have a terminal that squeeze onto the positive and the negative, and that's what creates the series link of all the batteries. Then we have some cables on the front, and that's your expansion cabinet.
With the cab in position before we could start wiring it up, which would come with its own very, very troublesome issues, all that was left was to fill it up with raw battery storage.
These are the batteries that are going to go into that cabinet. So there are 1, 2, 3, there's 8. No, there's not. There's 8, there's 10, there's 12. And they are 8 kilowatt hours each, I think. So it's like 96 kilowatt hours of capacity. Total usables about 85, I believe. But these are really heavy compared to a domestic battery. They're a lot heavier because they're thermally managed. They've got cooling fans in them, you've got comms on them. These are those connection points, that buzz bar we saw before. When the battery slides into that carrier, it will collect into there, and that is what makes the power connections. Oh my God, they're heavy.
Go on then, lift it out.
Why are they so heavy?
We load them on our own. Come on.
They are heavy. That's like a power wall.
Now, it was only as we started to install the cells that we noticed something very wrong with this expansion pack.
Will you ring Andrew Bailey? But we're going to go down, across and up, is it? So
Just have a gap between them. You can get longer ones of them, sort it out. The issue is, before you stack these up, you have to have a gap, aren't you?
I could put a 70mm hole in the bottom, so we go down through the bottom and up, like these. We can do that, that's not an issue. This has to be sealed, obviously for the IP rating and things, isn't it?
So, not only was the cable too short, but we started finding more incompatibilities between the non-IP rated expansion pack and the regular H50.
Look, I don't think it will actually make it across because it's the height. Well, it's the height
they are
difference.
wider.
It's wider, and there's a height difference as well. It's about a foot taller, and you can't go through the top to get the access. You're going to have to go on the right-hand side because of the AC.
Okay. Straight away, I got on the phone to our Alpha contact to see what we could find out.
The extension leads that will go from the cab to the master battery
We need the AC, the PCMU, and the pos and net.
are all really short.
Okay. Is that going to cause us trouble?
All I'm sort of asking for, can I get an IP-rated cable kit, and I can make it work with the internal cab?
Yeah, I'd have to check what we've got in stock. Let me make some phone calls now. Yeah, because I'm going to have to strip one out of a stock unit, and it means I'm going to be short on a stock unit.
Yeah. We can swap you. We can give you a small one.
Yeah.
That's some big white goes, isn't it?
So we left the issue with Andy for a while, and when he came back to us, it seemed like we might have actually found a solution, but it would require work from both ourselves on site and Alpha at their head office.
And this is the issue. So it turns out that the indoor unit is different to the outdoor unit, like we just said. The cables aren't the correct length. On the other battery, they went down, through the bottom, up and round over here. But obviously, these aren't gonna fit and we can't just put them like that. Now we've spoken to Alpha, haven't got any in stock in the UK. What they're gonna do is air freight them from China. That's gonna take about 5 days. And what we've had to do is at the bottom of here is make a hole. So we're going to get a grommet to put in there. Then that's going to allow us, there it was, that was where it came out. That was the old metal there. The cables will drop through there in that grommet, run under. They're going to pop through this hole here where this grommet is, drop through, come up and connect onto the positive and negative terminals there. So now they might not arrive in time for us to commission the parallel system. So what we'll do is commission the parallel, i.e. one H50 over there, one H50 over here. And then when those cables come, we'll come and just expand the system, and then we can update the commissioning to say it now has more storage. It's not the end of the world, it's just a bit of a delay. Yeah, it's not the end of the world, it's just a bit of a delay. It's just a bit of a delay. A bit of a delay.
This is a month down the road, and looking back, how wrong was I that 2 cables were going to get us out of this mess. This turned into an absolute nightmare, and to see what happened, you're going to have to watch the second episode of this install series. I didn't enjoy it, but you might, so we'll see you there.
Who needs toolboxes when you've got a Tesco shopping?
Strongbow cans.